A transistor is a device that can be made to behave like a switch. When a switch closes, it causes the two different parts of a circuit that it connects to be at the same voltage. When a switch opens, it prevents any current from passing through. When there is no current flowing through a light bulb, both sides of the light bulb are at the same voltage. The end of the light bulb that is connected to the battery will always be at the voltage set by the battery. The other end of the light bulb will be either at the voltage set by the battery or at 0 volts, depending on whether the switch is open or closed. The same thing is true of a device which we call a resistor. If we replace the light bulb with a resistor, it will behave the same way. Suppose we also replace the switch with a device called a field effect transistor. This transistor has 3 terminals, which we will call gate, source, and drain. The terminals which we called source and drain go where the terminals of the switch used to be. So far, we have not yet connected the gate terminal to the rest of the circuit. If we apply a voltage to the gate terminal, the voltage that will exist between the gate and the source will determine whether the transistor behaves like an open switch, a closed switch, or something in between. If the transistor behaves as something in between a closed switch and an open switch, the transistor can be used as an amplifier. Small changes in the voltage on the gate terminal will create much larger changes in voltage on the drain terminal. However, in our case, the voltage that we will place at the gate terminal of the transistor will always be just one of 2 values. Either this voltage will be the same as the voltage of the battery, or it will be at 0. With this particular type of field effect transistor, if the voltage between the gate and the source is at the voltage of the battery, the transistor will behave like a closed switch. If the voltage between the gate and the source is 0, then the transistor will behave like an open switch. Let us call this part of the circuit the input, and let us call this other part of the circuit the output. When a part of the circuit is at 0 volts, we will say that it is at logic low. When a part of the circuit is at the voltage of the battery, we will say that it is at logic high. We have now made our first logic gate. When the input of our circuit is logic low, the output of our circuit is logic high. When the input of our circuit is logic high, the output of our circuit is logic low. This is the definition of a NOT logic gate, where the output is always the opposite of the input. To make a more complicated logic gate, let us consider a circuit with 2 switches. In this case,